Hello, friend. My name is Derek Carter, and this video, we're going to be looking at the steps you need to do in order to set up and use the class resources repository. So this video is for my operating systems class, the versions of my operating systems class where we're using the xv6 operating system. So xv6 is a reimplementation of version 6 of the Unix operating system, which was built in the late 70s, early 80s. And it's really mainly a teaching operating system. So basically, you need to be able to have this code. You need to be able to look at it, but also compile it and run it in the debug mode. That's really the main way that you're going to be learning stuff about this class. So you're expected to actually, look at the code, use the code, and understand from reading the code. So the textbook and my video lectures and things like that are really kind of secondary or supplementary to understanding how an operating system works by actually looking at and modifying and running the code. Okay, so with that, let's go ahead. Actually, before I get started with setting stuff up, this video assumes that you already have Git and Docker installed. And for my class and class videos, I'm actually going to be using VS Code and what are known as DevContainers, which really are a way of integrating Docker containers in a convenient way inside of running VS Code. So you don't necessarily need to use VS Code, but you'll see me using it, and I find it very useful to actually run a Docker container in VS Code that's running all the tools and things so that we can compile and run the QEMU emulator for the xv6. Okay, so anyway, I mean, this assumes that I'll have a link to the description in this video or into the class resources. So you do need to have Git and Docker installed and VS Code installed, all the stuff set up before you come in here. Okay, so I'm going to start by just cloning the repository and then reopen it in a Docker container in VS Code. Right? Let me go ahead and do that then. So for my class, there should be a link. Look at the getting started or the class resources, but there should be a link to to a GitHub repository that I usually call the class resources repository. So I'll talk a little bit more about this, but in order to use this, and you'll definitely need to use this for the class here, you want to clone this repository. The repository isn't meant to be, give you access to be able to write and modify it for us. You'll have to clone it using the HTTPS URL. This essentially allows you to get a read-only or to download the code. I mean, it's still a Git repository. You could actually make changes and stuff, but you just couldn't push the changes back up. You'd have to push them to your own copy or a different repository. So anyway, so this is just the normal usage of Git here. So, for the class resource repository, get the HTTPS URL, copy that, and then however you normally do a git clone, you just want to go ahead and clone that repository. I mean, if you're using VS Code, an easy way to do it is from the source control tab. We can do a clone repository, just paste that URL in there and clone it from the URL. Okay, so I always put all my repositories into a particular directory to hold all my repositories. So I'll just go ahead and select there as the local place where the code is copied into. You shouldn't get this warning here. Let me fix this. Okay, yeah, I had forgotten when you clone using HTTPS, you might have to go ahead and allow it to do like a login to GitHub for some reason, which is a little bit counterintuitive. But just go ahead and allow that, and it'll pop up in a browser if you're not already logged into GitHub. But the result should be that it should just, if you're cloning using HTTPS URL, it should make a copy of your repository down to your local directory. Now, like I said, this video isn't about setting up Docker and stuff. If you've got Docker and everything set up, you should get a pop-up asking if you want to reopen in the container. This is the thing that uses the Dockerfile in order to create a Docker container and run it in VS Code in what are known as DevContainers. If you don't see that pop-up, you might not have Docker running. Check that your Docker desktop is running, or something might be wrong. But you can always try. If you don't see that pop-up, you can always go to the, you need to have the DevContainer extension installed. So if you don't have the DevContainer extension installed, you won't have the Remote Explorer. But you can try this is another way to create a container that hasn't already been created. You can go to the DevContainer's Remote Explorer and do a plus, and just since I already have this folder open, that I want to use the Dockerfile to create the Docker container, and I'll just say open the current folder inside a container. Okay. So either way, but it's easiest if you see that pop up just to say yes and go ahead and have it reopen in the container. That usually means that you do have Docker up and running and everything's set up correctly. So the very first time you do this, this might take some time. So I'm just showing the build. So this is doing like a normal Docker, what's it called, a Docker run, the Docker build process using the Dockerfile. So again, pause this. The very first time you do this, it will have to download a bunch of cached images and things, so it can take some time. Normally, once you've done this once, if you need to recreate the container for any reason, it won't take as long because stuff will be cached on your local system and things. So we go ahead and pause. So if you successfully create a Docker container and running it in there, and if you're using VS Code, the DevContainer, you should see that, if you look at the bottom left hand, here's an indication that we're actually running in the DevContainer. Another way to check in VS Code is if you open up a new terminal, you can kind of tell from the prompt here that we're actually in the xv6 OS container running on this workspace here. So let me just mention, in this container, there's a couple of other resources. If you look in the doc subdirectory, there's actually a copy of the open source textbook. This is actually the copy of the version that I use, where I put my notes and highlighted the text stuff in there, so you can use that. There's also the source booklet, which I'll mention in a bit here. All the slides I use for the lecture videos for the class should be in the slides subdirectory. So there's source files, but there's also should be the PDFs of the built slides. All the code examples that we use when we're discussing stuff in the lecture videos should be in the code subdirectory. And I'll also show an example in this video of this. So those need to actually be copied over into the xv6 code if you want to actually compile and run them to follow along with the discussions in the lecture videos. And then finally, there's a xv6 subdirectory. But initially this will be empty. So this video I'm going to show setting up your xv6 operating system code and compile it and run it in there. So just real quickly back to VS Code, just to repeat that. So there is a docs subdirectory, and you should find a copy of the PDF of the book. You'll have to open up your local file browser and browse to that. And there's also this the book is this one here. You have to open that up on your local file browser to look at a copy of the book. All the source code examples will be in the code subdirectory here, and all the slides for the lecture video should be in the slides directory. And then we're going to actually put in the source code for the xv6 operating system in the xv6 directory. Initially, it's not completely empty. There's some patch files in order to patch up the build system so it works correctly in this environment. But otherwise, we don't actually have the xv6 code in here yet. So the next part of this video, if you're at this point and you're ready, you need to get things set up so you can actually compile and run the xv6 RISC source code. I'm basically following the instructions given in the README file for our class repository. So we're gonna test that our installation is working. Then we're gonna do the source code setup to get the xv6 RISC source code, and then I'll show an example of compiling and running it, and I'll show also compiling it and running it using the GDB debugger, so you can actually get it into it with a debugger and run the operating system kernel code and step through it. And then I'll show using sort of the lecture source code examples, how you get those in and compile those in if you want to do things. So if I go back to my browser here, so I'm basically using the instructions on the README here, starting with the testing your installation here, okay? So so as is mentioned in there, second. So as are mentioned in the instructions there. If the first thing you want to do is test that you've got the tools. Okay, so if you're running in the DevContainer, however you start up the Docker container, you should be at a command prompt right inside your Docker container. So all of the cross-compilation tools and the QEMU emulator should have been installed for you. So as a quick check, I mean, there's lots of things that need to be in here, like the correct version of make and other stuff. But as long as these two are there, so if the RISC-V compiler is there and in your path, that's the first thing. So this is the compiler that's used to cross-compile the xv6 code. So we need a RISC-V version of the GCC compiler. So, you know, if you run that and you get an error or something or can't find it, something might be off, or you might not actually be running a container. So you should probably see like version 14.2 or maybe something even newer, depending on when you're watching this video from when I made it. You also, it's important to have the quick emulator, the QEMU emulator available that can run the RISC-V. So you might want to check that one's available. So you should find like version 10 or above of that in your system here. So, so assuming those are available, you can go ahead. We first need to set up the xv6 code. In your repository, there is an xv6 directory. But if you look inside of it, there's the code isn't there yet. We could have put the code in this repository, but I decided it would be better to just do a git clone of the official working repository of the code, just so that, you know, because it is still being kind of worked on. So whatever is the latest version that's out there in the repository, we'll always clone that down here. So if you run a make setup from the top level of the class resources repository, this is actually just doing the git clones. So you can do this by hand if you want to do your git clone. And it's safe to rerun the setup. So if you already have it, it'll try to do a pull so that it'll pull down any other changes that have been made since the last time you did the git clone there. So it is safe to rerun this. It's also safe to do a make clean here. So this might take a little bit of time to clone this. It is safe to do a make clean. This will just delete these xv6 source code repositories, which if you mess something up, it might be necessary for you just to delete everything and reclone them from a fresh version, so that you're back to a version that you can correctly compile and run. Okay, so the clone was done. So now if you look in that directory, you'll see that there's an xv6 RISC-V, and the book has the LaTeX book source code in there, which I might briefly talk about. So you can see in VS Code, in the file explorer for VS Code, that you can see those directories now under xv6 here. So the xv6 operating system source code is in the xv6 RISC-V directory, which is our xv6 subdirectory here. So and it is also using make, which is just a simple build system. So to make the code and actually start it running in the QEMU emulator, just first change directory into xv6, the xv6 RISC-V. Okay. So if you look in there, I mean, most of the code for the kernel is under the kernel code there. Most of the user program code that we'll use goes under user program, and yeah, there's only one other subdirectory there. So all you need to do is do the make with the QEMU target. Okay, so this should usually compile real quickly. And again, you know, this won't work if you don't have all the tools and stuff set up that you need for it here. But this will just scroll by real quickly here. If it succeeds, it actually, let's see if we can find it here. Right here, the last thing is, so everything up above this was actually compiling all the code together and creating the kernel. And then here was actually invoking the QEMU emulator. And it runs that kernel. So basically we're emulating a RISC-V system and we load in this kernel, and the other things are the amount of memory and the number of CPUs, and device drivers and things to use. So, as I kind of mentioned in the README, by default, although it's a bit strange, I don't know, we might later talk about why here, but it actually starts up 2 virtual CPUs. So HART stands for hardware thread. That's the RISCV term for like a CPU core or a CPU processor. So there's actually 2 CPU cores running here, and this is running a simple shell. So if you're familiar with like Bash or other shells, doesn't everything, but you know, you can do some simple. You can basically start other user programs from the shell here. All right. So if you need to get access back to the emulator, you can use the Control A key and I just hit Control AH to print out this help message. So, you know, if you need to send a break or do some other stuff, so the most normal thing you need to do is you need to exit the emulator, right? So there's no way to actually exit out of this emulator except for using the Control AX to get back to your actual Docker container that's running. So I'll hit Control AX to terminate the quick emulator session there. So sometimes you might need to ensure that everything is rebuilt from scratch. So you can do a make clean right here. This actually just will delete all of the intermediate build products, so that to ensure that when you do a build, everything is completely rebuilt. So you don't have to do that very often, but sometimes things get a little bit messed up. So if you're having some strange problems, it's often a good idea to do a clean and see if they're still messed up. Then if everything is rebuilt, like I just did there. Okay, so that was our README instructions on setting up the source code and then doing a build and running the quick emulator. So let's show running the emulator in debug mode, so you can access it from the GNU debugger, the GDB. There'll be another video with more information about using the GNU debugger, but I'll just show you how to get it started and connect to the debugger here in this video. Okay, so you know it's similar to before, although here I'm going to specify the number of CPUs. So this will only use this will actually the main effect of this is to start the QEMU emulator with just a single CPU instead of the 2 or 3 CPUs that it normally starts up. And then we just change the target to QEMU-GDB to start it up in the debug using the debugging mode, the GDB debugging mode. Okay. So as I mentioned, so same thing happens here. It builds all the source. The last thing that happens is it runs the QEMU emulator again. It did change this option here to only use a single CPU, but it added on some flags here, so it's running in the GDB mode, so it's running in debug mode, and it's opened up a port on port 26000 here that you can connect a GNU debugger to in order to step and run through the program. So to do this, you have to open up a second terminal. The terminal needs to be running inside your Docker container. So like in VS Code, you can open up multiple terminals by doing the plus on the new terminal or doing the terminal on new terminal. This, you need to change this to that same directory, right? So when I open that up, it'll put me back into the top level of my workspace here. So I'll change the source code. If you look here, this should have created a file. It's going to be hidden, so you have to use like a LL or ls-alh to see this. So it created a .gdb init file here. So you can look at the contents of that. So basically what this is really doing is if this file is locally, when I start my GDB, it'll open this up. This is basically telling us to look on the local machine, port 2600, to connect my debug session to, as well as other things like use the RISC-V architecture, 64-bit architecture, and some other stuff. There is one thing missing from this. So as is noted in the instructions, you can run this command here. I'll just copy and paste it. So this creates a directory called, on my home directory inside the container, called GDB, and then it echoes this line out to the GDB init here. You could also create this just in VS Code. I could do like an open file. I have to go to my home directory. So within the container, this is a running unit Linux operating system inside the container. So I can go up to my home. Your username is actually called student inside this container. If you're using my container Dockerfile, we'd have to create the .config directory here if we don't already have it. So I guess in this interface there might not be an easy way to create a file to create a directory here. So I'm going to actually escape out of that. And I'll only run this first command. So this will actually create the directory called config GDB. So let me try that again then. So I'll do a file, open file, to my home student directory. Now there's the config directory, GDB. Here I want to, I guess I probably just had to create like a new file. So I want my GDB init file here. See if it allows me to create that. So yeah, I guess I'm just going to have to do like a file, new file here. So I'll just do that, put that line in there. So you basically need this line here, the set auto load safe path to just be the root, right? So I mean, this is a little bit unsafe, but I'm not too worried about security in this environment, especially right inside of a Docker container here. So now I guess if I save this, it'll allow me to go to config GDB and save it as the name. So it should be saved as the name GDB init without a dot in the front, right? So basically when you start GDB, it'll look here for default options and load those before then it looks for the .gdb init in your local directory that you run. So either way you do that, or I could have just done the command from here, but I should now have a file called GDB init in my config GDB directory, which has that set auto. So let's just check here. I mean, if I go back to my other terminal here, so you can, there's kind of like a tab interface. All the tabs are on the sides to the top. If you're using VS Code again, but yeah, I mean the run of xv6 is still in the emulator, is still here. It's still actually paused, waiting for something for a GDB session to connect to it on the port here. So let's go ahead and connect to it. I'm going to use the text user interface mode. So you'll see what it looks like here in the video. I didn't have like a screenshot of this in the instructions. So this is another tool that should have been installed as part of the packages that are installed in the container, a multi-architecture version of GNU debugger, and we'll say that we want to run it in this text user interface mode here. And I'm going to make all the stuff about as big as I can here before I start this. All right, so we're actually running in the debugger now. We've actually connected to that port 2600. So yeah, it's still paused there. So we have to hit return here when you do it in this mode till we get to the prompt for the GNU debugger. Maybe hit it multiple times here. So at this point, what I would normally do, like I described in the instructions, is set a breakpoint maybe at the entry symbol or the entry assembly code. You can also set a breakpoint at, say, for example, at start. which is the first function that entry ends up calling, which is the first function that's actually C code after the assembly entry point that happens. More on this in the course here. We can do a continue. Okay. So when we do this, it's actually started running, but it broke on the first instruction in the entry. And again, this is all RISC-V assembly code here that does a couple of stuff that we will talk about in this course, and then it calls start, which is where it will jump over and start executing that was compiled from the start.c file. So we can do, again, there'll be another video about this, but we can step over these commands. I can hit C here to continue on, and it should then break at my second breakpoint in start. So this is C code. So from here, I could do like steps or nexts to step through these codes. Here, if you go back and look, still the original run of the emulator doesn't look like it's doing anything because it hasn't gotten far enough to actually run the init process and start up the shell. So if I just continued on from here, we would actually now get continue doing the boot process, and the shell would start up. It would be running. Okay, and I'm still in the debugger, so I could do something to actually interrupt the running process, or I could just do the normal Control A exit here. So when that terminates, my debug session should notice that it exited. We can do it like a queued exit out of there. Okay, and then finally, I just wanted to mention, if you're interested, you can also actually build the book, the open source book for the xv6 operating system from the source. So there's a second directory called xv6 RISC book. As is mentioned here, there's some additional packages that need to be installed. These take some time, so we don't install these by default. So you might want to do this. The copy of the book I have in the docs subdirectory has my own notes and highlights. But if you want to make your own notes or highlights or stuff, or if some changes have happened to the book and you need to get a copy of the most recent version of the book, you might want to do this because this will clone from the repository that holds the most recent version of the book that was pushed to the main branch, and so you can make a build of whatever is the last most recent version of the book that was made. So to build the book source code, you want to go back up one directory and go into the RISCV book and do a make from there. But this will fail because we don't have all the LaTeX stuff installed. So as is mentioned in the instructions, you basically need, if you look in the Dockerfile, it's commented out by default, but it's this stuff here, the Pandac and the TechLive, all these packages are needed, and it will take quite a bit of time to install these. And you do need to do like an sudo command. So all this stuff in Dockerfiles run as the root user. So if you're doing it by hand, put sudo for super user do in front. I'll just put all those on there. So like I said, this will probably take 5-10 minutes or so to get all this stuff installed here. So I'll pause while this is installing. Okay, so that might take a little bit longer than I said, but once that's done, the build should succeed. So once you have the LaTeX packages that are needed, if you just do a make, the result will be that you should get the two PDFs, the book PDF and then the source code booklet. So again, this won't take so long, but a lot of output will scroll there. But if you do ls, you'll see these, right? So these, if you want to have your own copy of the book, it should have been built here in the xv6 RISCV book subdirectory. Just a final thing. This is actually the copy of the book in the docs subdirectory. So if you look through here, you'll see that it has my highlights, and I actually have notes different things there, which you may not find useful. But I'll just mention, so these blue links in here are actually the number here. It represents like the page and the line number on that booklet of the source code. So I don't really find that useful. If you click on the link, it will actually take you to the online GitHub page, which is usually correct. Just show that here real quickly. So if we click on that, it'll take you to the GitHub version of the page here. So that was just a link to like line 1 of the shell.c in the user directory. But yeah, I don't find this particularly useful. So for example, what I would normally do, let's go down here, look at like the next link here. So like this one here, or maybe I'll pick this one here. So, hopefully you have a good PDF reader. If you hover over that, you'll see that the link is to the user shell.c line 55. Okay, so that's on page 80, line 3 of the booklet. But I like to just open that up. So this is the run command in the C file that's actually the basic shell that's run by the init process when xv6 boots up. So I think it's better to actually open this up in your text. So the user code. So all the code should be under the xv6 RISC directory if you set everything up. Kernel module code is going to be under the kernel subdirectory. User code like shell.c will be under the shell subdirectory. And let's find shell.c so we can open that up. And then the line number should be correct, so they should correspond. So the textbook line number for the run command that I was hovering over was line 55. So we should be able to go down here and find that the run command was at line 55. Yeah, that's right. So so it might be slightly off. So we actually had the prototype of the run command, which was just a little bit. That was the first occurrence of what the run command was in here. But the point is that let me make the point again here that the source code really is the primary learning tool in this course, not the textbook. So, but if you're reading the book, do follow and read through the code when you have these links to it here, and you may or may not find it useful just to click on the link and browse through it on GitHub. But I encourage you to, like in this case, this is referring to the main function, which should be found in the user, the shell.c, which is in the user code at line 146 and so on, right? So you can read those links and just bring it up in your VS Code editor and look at them that way. Okay, so that's it for this video. As usual, I hope you find these useful for you. Let me know if you have comments, and definitely if you have questions, ask them in class. Just a reminder of kind of what we've been on this video. The purpose of it was to make certain that you know how to use and set up the class resources repositories. Specifically and especially, you need to have a working version of the xv6 source code that you can compile and run in the emulator. All right, so we showed doing that in this video. I will have links to the stuff that I mentioned in here, to the, you need to actually have Git and Docker set up before you can do the stuff we showed in this video. So look for those links in the description for this video or in the class additional resources or getting started resources. Okay, that's it. Hope to see you in class.